At this point, you're probably wondering, are there really two different ways in which we can pass arrays as arguments to functions in C? After all, we have seen this square bracket notation here and also in many other examples before. But in the previous video, I had also showed you this pointer-based syntax that seemed to be doing the same thing. And it turns out that yes, there really are two different ways in which you can pass arrays as arguments to functions in C. And it's really up to you to choose which style you prefer. Now, when we had seen this version of the min function, where the third argument was an array of one integer, I had showed you this main function, where I had declared in the main a local variable ans, which was of type array of one integer. And then when we had called the min function, we had just given this ans the name of this array as the third argument to the min function. Now, something very important to know, whenever you talk about the name of an array, the name itself is a pointer. It's an address. And it's pointing to the 0th element of the array. So this ans is really the address of the 0th element of the array. So we can write it like this. The name ans is just the address of ans 0. This address is called the base address of the array. So the crucial fact to remember is the name of an array is always an address. It's always pointing to the 0th element of that array. Now that means we can just replace this with address of ans 0 and it should mean exactly the same thing. These two expressions are equivalent. Well, what is address of ans 0? Ans, we have said, is an array of integers. And that means ans 0 is an integer. And so address of ans 0 must be a pointer to an int, something that can hold the address of an int. So over here we are passing an int star value. That value is being copied over into this parameter, and that means this parameter should have type int star. So it turns out that it's perfectly okay to rewrite this like this, and it will work just fine. So this is an int star. It is capable of holding the address of an int. And the reason it's compatible with what we wrote earlier is when we passed just ans, that really was the address of an int, the address of the 0th element of the array. So there is absolutely no mystery why everything we have made, the changes we have made, will work perfectly fine. Now, if we go over here to the main for a minute, we had declared this array of one integer. And in the earlier video, we had said, well, let's just replace this with just a single ans variable, ans of type int. In that case, we have to pass the address of that int variable. This is also a pointer to an int. So once again, this change, this version of the main function is compatible with this min function. It will work perfectly fine if we make this change. Now you might wonder, well, this is a pointer to an int, but here we have used this array notation, ans square bracket 0. Is that going to work out? It is going to work out once again because of this equivalence. So let's look at this equivalence again. Suppose we apply the star operator on both sides of this equivalence. So what is star ans? Well, star ans is obviously star of address ans 0 because we know that ans is just address of ans 0. And what is star of address of ans 0? Well, ans 0's address is pointing to this integer. And if we take that pointer and star it, meaning dereference it or look at the int that it is pointing to, well, that's just this integer itself. So star of ampersand ans 0, the star and the ampersand cancel and we're just left with ans 0. And that means in this code, wherever we have used ans0, we could just have written star ans. And that's the syntax that we saw in the previous video. So everywhere we have done this, we could have written star ans. We can do either one. If we prefer this syntax, if we think this syntax makes more sense, we can use it. But if we think this syntax makes more sense, we can use that as well. So what we have ended up with is an equivalent piece of code that works exactly the same way. And the reason these are all equivalent is thanks to this key fact. So if we just step back and observe what we have done, we used to have an array type argument here. And what we have just seen is that it's absolutely okay to replace that array type argument with a pointer type argument. And this can be done always. So you might think, well, what about here? Can we also replace it here? And the answer is yes. This is also acceptable. Now you might say, wait a minute. In the earlier version, this n referred to this argument. So this was indicating the length of this array. And if we just replace it with star x, then aren't we losing that information? How can we be sure anymore that this array really has length n? We cannot be sure that it does. But it turns out that even in the old syntax, we still can't be sure that the array really had length n. The only reason why I personally prefer this syntax is when we are reading it, it's very clear that here we're talking about an array whose size is at least n, and this n is one of the arguments that is given to the function. If we look at this syntax, then there is no connection between this x and this other argument n, and so we as programmers have to work a little bit harder to realize that in fact these two arguments are related, namely this is the length of this array. So I personally prefer this syntax, but some people prefer the pointer-based syntax, so you should be familiar with it. An important point to remember is that if you are using this square bracket notation, then you must declare your variable that holds the length, the argument that holds the length of the array first, and only then use n over here. Whereas if you're using the pointer-based syntax, then you could have declared the pointer as the first argument and the length as a later argument. And in fact, that's what many people do. So it's something to be aware of. So this still leaves the question, why are arrays being passed like base addresses? Why are they being passed as pointers? And this is the question we'll resolve in the next video.